This video is going to pick up with the practice problems from Unit 8, Day 1. Okay, so I'm just going to go through these 4 practice problems, so feel free to skip through this video if you don't need the help, if you feel like you're confident with it, and then you can just check your answers using the answer key. So I have a function, f of x equals 3 times 2 to the x plus 1. Think first, is this exponential growth or decay? Hopefully you said growth because the 2 is greater than 1. So first step I'm asked to do, find f of 4, just a number, an x picked. When I plug in 4, I get 2 to the 4th power times 3 plus 1. That is going to be 47. So if I were to graph this, I have a few dots. If I were to graph this, I'm going to do 1, 2, 3, 4. I'm going to go up by 5s. 5, 10, 15, 20, 25, 30, 35, 40, 45, 47. So I'm scaling my y-axis by 5s, okay? And my x I'm keeping normal. Now, question B, find x if f of x is equal to 13. Well, I would plug in 13 for my y, set that equal to my function. Subtract 1, divide by 3, and I would find that for 4 is equal to 2 to the x would be 2. So I'm going to go ahead and graph that as well. X is 2, 5, 10, 13. Okay, so I have my 2 points. Because I know that this is exponential growth, I know that this is going to, actually, before I do that, I'm going to use my knowledge of what I've been doing, right, and look back up here at the general form of an exponential function. So h, do I have an h in this example? No, I don't. So it's not moved to left or right. K moves the graph, though, up or down. So my graph was moved up by 1. Okay? So normally I would have, with a base of 2, I would normally have 0, 1 as my intercept, but now I can't because it's been moved up 1. What happens when I plug in 0 for x? I get 3 times 1 plus 1. So I actually have my y-intercept is 0, 4. So I'm going to plot that as well. And now I know that my domain and my range, I can identify those. My domain is all real numbers, and my range, well, moved up 1, so therefore I start at 1 and I go to infinity. So that's my asymptote, y is equal to 1. So I'm going to go ahead and graph this, and I know it doesn't, I know it doesn't look like I have a horizontal asymptote at y is equal to 1, but I do. It's just that my y scale is so much bigger. So pretend that, here, how about we use this? There is a horizontal asymptote here at y is equal to -1. I apologize for that being such a ratchet graph, but hopefully you get the idea of what it's going for. Question F is asking, let's say I give you g of x is equal to 6 to the x plus 1. Are those the same? What do you think? What do you think? They are not. No, no, no. They're not. Even just think about your y-intercept. If I were to plug in 0 into this function, I would get 6 to the 0th power is 1, plus 1 is equal to 2. That is not equal to, oh, I picked the wrong pen to use. That is not equal to my y-intercept here, which was 0, 4. Okay, so they're not equal. Alright, let's move on to these bottom examples. So for these ones, what's going to happen is I'm going to graph these using the starting point of 0a. So that means find your y-intercept. And 2 other points, then graph it. You'll state the domain, range, and asymptote. So let's think about number 2. Let's first off start by plugging in the point where x is 0. So if I were to plug in 0 for x here, oh, I got to get rid of this pink. Great. If I were to plug in 0, I would get 2 times 3 to the -2 plus 1. This 3 to the -2, I know would move it to my denominator, so it would be 2/9 plus 1, because it would square it as well, which would be equal to 11/9. So we have 0, 1, and just over 1. Okay, where that little green dot is. I'm going to zoom in to make it a little bit easier to see. There we go, that's better. Okay, now let's think about what are the transformations that happen. So if we scroll back up, here's our general form, x minus h plus k. H moves the graph left or right, k moves the graph up or down. We have x minus 2, so that minus 2 will move it where? It will move it right 2. And then the plus 1 moves it up 1. Okay. So let's identify next our domain and our range. So our domain we know is going to be negative infinity to infinity. And our range, well, since we moved it up 1, that means we start at 1 and we can go to infinity because this is exponential growth. And our asymptote we know is y is equal to 1. So let's graph it. I'm going to zoom in, make it a little bit easier to see. So what happens when I have the point, I think that's a little bit too much, when I have the x is equal to 0. When I plug in x is equal to 0, we found that that was 11/9, we already graphed that. When x is 1, I get 2 times 3 to the negative 1, so my 3 goes in my denominator, so I get 2 over 3 plus 1. 2/3 plus 1 would be 5/3. So that's 1 and 5/3. What happens when x is equal to 2? I get 2 times 3 to the 0th power, so that's 2 times 1, plus 1 would be 3. And then last, we can do one more. What happens when I have x is equal to 4? I get 2 times 3 squared, so 18 plus 1. Oof, that's up here. Okay. And I have my vertical, or my horizontal asymptote at the line y is equal to 1, which is right here. So my function is a small graph, but I never cross that horizontal asymptote, and then it's going to keep decaying, so it's growing pretty quickly. Okay. Alright, our second example, so I've already written out a part of it, but I can identify from the general form that this plus 1 will move it left 1, and the minus 2 brings it down 2. Okay. My domain, of course, is going to be all real numbers again, and now my range is going to be what? -2 to infinity. Okay, so my horizontal asymptote is at the line y is equal to -2. So let's plot some points. So what happens when I plug in x is equal to 0? I get 2 times 1/2 to the first power. So 2 times 1/2 is 1, minus 2 is -1. So I get 0, -1. What happens when I plug in 1, and what happens when I plug in -1? So if I plug in 1, I get 2 times 1/2 squared minus 2. So it's 2 times 1/4, which is 1/2, minus 2 would be 1.5. Then when I plug in -1, I get 2 times 1/2 to the 0th power, which is 1, so 2 times 1 minus 2 would be 0. And I know that this is going to never cross the line y equals -2, and it's an exponential function, so I can complete my graph. So we're just plotting points, right? It's pretty basic. Going back to some of the basic graphing that you've done, where you just take points, plug them in, and you know the general shape. Okay, last example problem that we have. Y is equal to -3 to the -x minus 2. So what I'm going to do is rewrite this -3 to the -x as -1/3 to the x to the x power, because my x is going to distribute here to my 1 and to my 3. And then I subtract 2. Excellent. So our domain, we know, is -infinity to infinity. Now what's our range? Well, we know that we're going to have to use this -2. That becomes our asymptote. Is our y is equal to k is our asymptote, so y is equal to -2. But now I'm curious as to what this graph is actually going to look like. What does this negative sign do? Well, this negative sign is actually going to take our function as if it were a positive exponential and reflect it over the horizontal reflect it horizontally over the x-axis, like so. So instead of having our values up here in the positive range, we're actually going to have negative values for our range. So that means that our range will be negative infinity to negative 2, because that's what the negative sign does. Let's see it. How about we plug in some values? So what happens when we plug in 0 for x? We get negative 1 minus 2. So negative 1, 2, 3. What happens when I plug in negative 1, for example? I get negative 3 to the positive 1. So negative 3 minus 2, I get negative 5. 1, 2, 3, 4, 5. What happens when I plug in like 2, for example? I get negative 1/3 squared minus 2, which is negative 1/9 minus 2, so it's just over 2. Okay, so I have my 3 points. Now what you can see is that I'm getting, as I get farther or more and more negative, I'm going to get more and more negative, and as I get more and more positive, I'm going to go right along that horizontal asymptote. Y is equal to negative 2. So this actually, even though it was 1/3 to the x, which would be decay, this negative actually switches it around and it looks like an exponential growth instead. Great, so that concludes this video on the 4 practice problems with exponential growth and decay and graphing.